So I wanted to make this quick video. There's a question on the homework that kind of covers these questions, so I just wanted to cover them. A couple vocab things here and some application of our derivative. As we move forward, we're actually going to be doing this stuff a lot more, so this is just a quick intro. So the question, you're given a derivative, and then it starts talking about horizontal tangents, and then it starts talking about where is it positive, where is it negative, or increasing and decreasing. So I'm just going to work through this example so you can kind of see that vocab and try it out on your own as we move forward. So what I'm going to see here, I'm going to start by taking the derivative of my function. So 6x squared, that derivative is 12x, and then the derivative of negative 12x is negative 12, and then the derivative of 7 is 0. So here I have my derivative. So when it starts asking where are the horizontal tangents, horizontal tangents are horizontal lines. The slope of a horizontal line is 0. So what we're doing is we want to know where is the slope equal to 0. So here's all my slopes. So I want to know when does my slope equal 0. So I'm going to take 12x minus 12, set it equal to 0 and solve. So what I'm going to do, I'm just going to factor this because I'm going to use that a little bit later. And it looks like this. And since my factor is x minus 1, I know that I'm going to have a horizontal tangent when x equals 1. Okay, and I think the question just wanted to know where we have that. So x equals 1, we'll call that good. Then the question extends and it says, well, where is the derivative positive and where is it negative? Well, if it crosses or it equals 0 at 1, it's going to be positive or negative on either side of that. So what I do, this is called the first derivative test. And again, we'll use this later. But what this does is it's going to help me find where my derivative is positive and where my derivative is negative. So I'm just putting this on a little number line here. And I know when x equals 1, my slope is 0. So I want to know on either side if it's positive or negative. So over here, x equals 0. Well, when x equals 0, I'm going to plug that in to see what's happening with my slope. So if I plug in 0 here, 0 minus 1 is negative 1 times 12, that's negative 12. 0 has a negative slope. That tells me every single value on this side of 1 is going to have that negative slope. So my derivative, my f prime of x, is negative. So I'm going to write this here, negative when x is less than 1. Okay? Then I'm going to test a point greater than 1, above 1. So I'm going to test 2. So if I take 2 and I plug it in, 2 minus 1 is positive 1 times 12 is positive. So all of these slopes are positive. It's a really ugly looking positive sign, but you get it. So from 1 above, all of those slopes are positive. And this is true for f prime. So f prime, the derivative, is negative when we're less than 1 and positive when we're greater than 1. So that's what's telling me about my derivative, my f of x. Then the question says, based off of this, what do we know about f of x? So the original function, the position function. So if my slope is negative, that means my function is decreasing. So f of x is decreasing when f prime of x is negative. So I'm going to say f of x is decreasing when x is less than 1. And then I know when my derivative, my slopes, are positive, my original function is increasing because the slopes are going up. So I am increasing when x is greater than 1. And then when x equals 1, it's neither increasing or decreasing because the slope is 0. That's what creates the horizontal tangents. I'm just scanning my notes over there. Looks solid. We're good. Hopefully that helps with the question. I don't remember what number it was, but good luck. Email me if you have any thoughts.